In problem 1, we have to find a relative extreme, specifically a relative max. So we want to know, where does f prime change from, let's see, to get a max, you need positive values to negative values. Well, first you have to figure out where f prime equals 0. Those will get us our critical numbers. So we need 6x minus 3x squared to equal 0. If you factor out a 3x, you get a 2 minus x left over. So either x has to be 0 or x has to be 2. Now, to figure out if you get mins, maxes, or neither, you've got choices. You can either use the first derivative test, where you chop up the number line and test sections, which I'll do here. Plugging in something like -1 to the first derivative gives you -6 minus 3. That's a negative result. Plugging in something like +1 gives you 6 minus 3, which is positive. And plugging in something like 3 gives you 18 minus like 27. It's negative. So your max results at 2, because f prime changes from positive to negative values, means f has a max. So we need a y-coordinate to go with our x-coordinate. To get the y-coordinate, you plug 2 into the original function. In this case, you would get 12 minus 8, which would be 4. So 2, 4 would be your one and only answer. Alternatively, you could have used the second derivative test, where you just plug the critical numbers directly into the second derivative. Plugging in 0 would have given you 6, which is positive. A positive second derivative means you have a concave up graph and the extreme's a min. Plugging in 2 directly to the second derivative would give you 6 minus 12, -6, which would be a concave down graph, which would give you a max. So, either way, first derivative test or second derivative test, your answer should be C.